What I'd like to do now is look at some problems involving vectors. For example, a vector v has an initial point of 7, 6 and a terminal point of 18, 7. Write the vector in the form ai plus bj. What we want to do here is we want to take the definition from earlier of a vector, and the definition was if you have a vector and you're given the initial and terminal points, then to denote the vector you subtract the x values and then you subtract the y values. In this particular problem we see that they want the answer given in the form ai plus bj, and so this is the form that we'll want to use to determine this particular problem. Alright, so in this case I'll go up and I'll label my points. I'll call the first one x sub 1, y sub 1, and then the second one x sub 2, y sub 2. And so I'll have from above x sub 2 is 18 minus x sub 1 is 7. That will be the component in front of I, and then plus y sub 2 is 7 minus y sub 1 is 6. That would be the component in front of j. And so this vector will end up being 18 minus 7 is 11i, plus, and then 7 minus 6 is 1. If you ever have a constant value of 1, you don't have to write it. And so you would end up with 11ij. Alright, before the next example I need to give you a definition. The magnitude of a vector is denoted by double bars around your vector, and then it's equal to the square root of the horizontal component squared plus the vertical component squared. So in this example, we want to find the magnitude of v if v is equal to negative 7i plus 20j. So using our definition, we know that here a is negative 7 and b is the 20, and so we'd have the square root of negative 7 squared plus 20 squared. Negative 7 squared is 49, 20 squared is 400, and we end up with the square root of 49 plus 400, which is 449. Now in these kind of problems, they may ask you to give a decimal answer, which you can obviously plug this in your calculator to get that decimal answer. If they want an exact answer, do make sure that the number underneath your root doesn't factor further, and there may be something that you could pull out from under the root. In this case, this particular problem is finished. The exact answer, square root of 449. Okay, another definition, to add or subtract vectors, you're going to combine their horizontal components and then combine their vertical components by doing the proper addition or subtraction operation. It's basically just like combining like terms. So in this case, if v is equal to negative 10i plus 5j and w is equal to negative 5i plus 3j, find v plus w. We talked about earlier in our definitions actually drawing v plus w. In this case, they would just want to know the resulting vector that would be the sum. Okay, on here, what we'll do is we'll say add the values that are in front of I first. So we'd have negative 10 plus negative 5. That would be the component in front of I. And then plus, add the components in front of j. That would be 5 plus 3j. And so in this case, we'd end up with negative 15i plus 8j. That would be the resultant of v and w. Okay, this problem says find the magnitude of v minus w if v is equal to negative 4i plus 6j and w is equal to negative 6i plus 3j. Okay, this is kind of a two-step problem. The first thing we'll want to do is find the difference of v and w, and then we will find the magnitude of that. Okay, the difference of v and w, what we're going to do there is we're going to subtract the components in front of I first. So we'll have negative 4 minus, be careful because the component in front of w is a negative. So that's that. And then plus, we're going to subtract the components in front of the j's. So 6 minus 3. That will be the new component in front of j. Okay, here we have negative 4 plus 6i. And then over here, this is going to be 6 minus 3 is 3j. And so final answer here would end up being 2i plus 3j. Okay, that's the difference vector. From here, we want to then find the magnitude of the difference vector. Okay, well, to find the magnitude of the difference vector, you take the horizontal component, which is 2, you square that, and then add the vertical component, which is 3, and square that. So 2 squared is 4, plus 3 squared is 9, and we'll end up here with square root of 13. Okay, and this concludes that lesson on problems involving vectors.